Okay, sorry about that quick interruption there. Okay, so you're going to look at the lowest temperature. What's the highest precipitation at the lowest temperature? And it looks like even when it's a really low temperature up here in the north, it's pretty dry, so we don't have that. But if we come down over here in California, our temperature's a little higher. So the lowest temperature at which we have high moisture is around there. Okay, and then the same thing, where's the highest temperature and the highest moisture? So we know the highest temperatures are right kind of clustered around here, and we do see the red brome in that area. So looking at our temperature graph, we're seeing this high temperature right here. Okay, but what's the highest precipitation we might see where the temperature is warm? And it looks like sort of this patchy area here in Arizona where we're seeing some of the red brome, and it's a high temperature and it's fairly humid. Now, not super humid, at 36 to 40 inches though. So with our high temperatures, we are at 36 to 40, so around there, but our temperature's not quite 90. We're more like 84 to 88, all right? So it looks like it might be around there, our dot, okay? And so our climate envelope for red brome looks about like that, okay? So you're just looking at the lowest temperature at which they occur, the highest temperature at which they occur, and then the highest moisture, what is the temperature, and the lowest moisture, what is the temperature, and sort of getting this graph. And you'll notice that, you know, as it gets hotter, the temperature usually needs to be high, or as it gets hotter, the precipitation needs to be higher to maintain the species. But in this case, red brome does really well in these hot, arid areas, and so you're actually seeing not quite that dramatic. Okay, so they're going to, and there's no right or wrong answer necessarily for this because the data is really messy. So they're just going to sort of try to get a feel for where these species are, and they should sketch them on their whiteboard so that they can compare them with each other and see if we want to adjust any. Okay, so that is, let's see, that is the part 2 of this activity, all right? And then once you have had the students look at these, compare them with each other, then you're going to present them with these 2 maps, all right? And they should have them already. But these 2 maps are precipitation and temperature under low emissions and high emissions scenarios, okay? So low emissions scenarios, this low emission model at the bottom, these 2 bottom ones, these are best case scenario. If we changed everything we're doing right now, stopped burning fossil fuels, everybody transferred over to solar or wind, and we did all low emissions, this is the change that you're going to see. This is the mean temperature departure. So how many degrees off from the normal will it be? And here is how many inches, let's see, percentage deviation from the normal for precipitation. The top is high emissions model. So if we just continue doing everything the way we're doing it right now, okay, what would you see? All right, and so given that, they're just going to look at their envelopes that they've made and see if it's going to make a drastic difference. Now, for red brome, the lower precipitation, and look, you can see where the highest deviation is going to be right where that red brome is, okay, where we got really dark green. All right, if we're under the high, even under the low scenario, this is where we're going to end up being really dry. And it looks like, though, red brome can tolerate pretty dry conditions, so it may not shrink the climate diagram this way too much. It is going to, we're going to end up with less of this stuff up here, okay? And then temperature-wise, though, we see that it doesn't go much above 90, and so under our high model, we're going to go upwards of 7 degrees, right? So going up 7 degrees, that's going to totally cut, you know, all of this down here is going to be gone, and all of this up here is going to be gone. And so we're really going to shrink our climate diagram to like right here, our climate envelopes. We're shrinking the available space in which red brome can actually survive. And it's going to be more dramatic with some of the animal species, where they can tolerate is going to be a lot lower. And that's really all they're thinking about here. You really ought to make sure you pay attention to the time constraints on the instructor guide for this activity. You don't need to make these discussions super long. Just getting the point across to them is enough, because you want to give them time to do their presentations, all right? And that's part 3 that I'll talk about here in just a second.